rural areas of Africa, river crossings are vital for daily life. Small bridges provide essential connections, enabling access to markets, school, and healthcare. However, designing and constructing these bridges in such resource-constrained environments requires careful consideration of materials and structural systems. In this week, we'll explore the most practical materials and static schemes suited for small river crossings in developing context. As for any civil engineering project, also for small bridges in rural context, a structured conceptual design is needed. Conceptual design is the initial stage of the design process where the basic concept is specified and local variables and constraints are taken into account. The main steps of conceptual design typically involves context analysis, evaluation and selection of the structural scheme, material selection, and preliminary design. The first step is understanding the project's environment, including topography, river flow, soil conditions, and the needs of the local community. This analysis helps identify potential challenges and define the bridge's role in the local infrastructure to answer to community needs. Regarding rural loads, small trucks or tractors might use the bridge. Although these vehicles are not as heavy as standard trucks, the load distribution may vary significantly depending on wheel configuration and cargo weight. Due to this reason, in the next video concerning the preliminary design, two alternative loads will be considered. Small bridges in rural areas face significant environmental risks. Seasonal heavy rainfall may lead to river flooding, which can raise water levels, augmenting the pressure on foundations, potentially threatening the stability of the bridge structure. Due to this, it's essential to carefully select the structural scheme and foundations. In developing context, limited resources and difficulties in transporting materials and structural elements to remote bridge pose major challenges. These constraints push designers to opt for simpler, locally feasible solutions that minimize logistics while still maintaining safety and durability standards. Once the context is understood, the next step is to select the most suitable structural scheme. The choice depends on factors like span length, expected loads, and construction feasibility. In case of rural fields, the most common options might include simply supported beams, integral bridges, or arch structures. Designs with central piers are typically avoided due to the short spans to be overpassed and to the previously discussed environmental risks. The main advantage of the simply supported beam bridges is the straightforward construction, making them ideal for remote areas. However, they can increase the risk of bank erosion, needing larger abutments and protection measures. Integral bridges provide better resistance to environmental risks as floodings, due to the monolithic pier-to-deck connection. Nevertheless, the alternatives significantly increase construction complexity, representing an insurmountable limit. Other solutions, as the arch bridges, are generally suitable for longer spans, offering excellent structural performance. The simply supported beam bridge appears to be a more appropriate solution as it is easier to construct and more cost-effective in rural, resource-constrained environments. Selecting the proper material for small river bridges depends on several key factors. Local materials, like timber and stone, are often the most affordable, cheaper, and accessible options. Durability is another important consideration, especially in environments with high humidity, temperature fluctuation, and seasonal flooding. Moreover, the compatibility between material and static schemes has to be taken into account. In rural Africa, timber is locally available, lighter, cost-effective, and relatively easy to work with using simple tools. Timber bridges can be quickly built and require minimal heavy machinery. However, timber has limitations related to durability. In fact, it can quickly deteriorate without a proper treatment. Despite these challenges, timber remains a viable material for short-span bridges, especially where budgets are tight and time is limited. Steel bridges offer a more durable option compared to timber. prefabricated steel components can reduce on-site labor and construction time. Steel generally offers high resistance but requires skilled labor for welding and assembly, which may not always be available in remote areas. Maintenance is also a key issue, as steel bridges need regular inspections and coatings to prevent corrosion. Reinforced concrete is a popular choice for small river bridges due to its strength and durability. Concrete can be cast into various shapes, allowing the use of different bridge schemes. Thanks to the steel reinforcement, it provides excellent load-bearing capacity and ductility. Proper mixing techniques and detailing are crucial to ensure bridge durability and long-term performance. In the conceptual design, it's not always necessary to proceed through the 4 steps in a strict order. Some constraints, such as material availability, may require a more adaptive approach. For example, if only certain materials are accessible, it may be essential to evaluate which structural schemes are feasible based solely on the available resources before moving forward with other design decisions. In this video, we explore the various materials and structural systems suitable for small river crossing in developing contexts with a focus on rural Africa. By understanding the strengths and limitations of timber, steel, and reinforced concrete, engineers can design cost-effective and durable bridges that meet the needs of local communities. In the next lesson, the preliminary design will be covered, introducing a basic design tool for such small bridges.